Okay, so recording has started now. So tank 1, 2, and 3. So with the tank dome, that's this line here, with all the valves and entries, connections to the tank located on this tank dome. And then aft of the tank, you have the pump dome with these two pumps here. Okay, that's 1, 2, 3. With here the reliquefaction plants and here the manifolds. I lost my presentation. Ah, here it is. Okay, so then about the lines. The lines is a little bit difficult to read, and that's why I add additional information here. So the upper line, which is going here on the top, you see that this one here, here at the upper left corner, this is the engine room. And in the engine room, we have the IG installation and we have the dry air installation that is located there. We are on board of an LPG carrier. You noticed already the reliquefaction plant, so that is an indication that it's an LPG carrier. And there's also another indication that it's an LPG tanker, since there are deck tanks. Here you have the deck tank on the port side, and here you have the deck tank on the starboard side. So normally one of two is a bit larger. You have one of almost 80 cubic meters and another one of something like 120. The smallest one is for ammonia and the largest one is for LPG. Why this difference? This has to do with the expansion coefficient. The expansion coefficient for ammonia is higher. What does that mean? That means that if you evaporate 1 cubic meter of liquefied ammonia into vapor at standard conditions, it will expand to, I don't know by heart, but it must be something like 600 cubic meters of vapor. While LPG is, for example, only 500 standardized cubic meters. So you don't need so much liquefied ammonia to fill these 24,000 cubic meters of volume as you need for LPG. Yeah, the size of this LPG carrier where we are looking at is mid-size gas tanker with just a total volume of 24,000 cubic meters. Okay, the line. So we have an inert gas line. Inert gas line is here and is running here upwards and has connections to the tank. We come back on that later. Here in my drawing, we are missing here a small part of the upper inert gas. I don't know how it is with your drawing, but here is missing a small part. So that is this inert gas indication is really the top here. Then we have a condensate line. You know, normally what is condensate? What that means? Condensate is vapor that has been reliquefied in our reliquefaction installation, in our cooling installation. So condensate is the return line from the compressor room towards the tanks. Then we have vapor line, we have liquid lines, we have again a condensate, again a vapor, and we have the lowest line here is the liquid line, which continues here, then liquid line to the vaporizer. And this drum here is our vaporizer. If you have seen one of the previous video, you know exactly what a vaporizer does and when it is used and where it is used for. So there are a lot of lines on deck, although not as difficult as, for example, a chemical tanker where you have a lot more of lines. Okay, sorry, liquid 1 and liquid 2, vapor 1, vapor 2. This 1 and 2 has to do with the system. I will come back on this immediately. There are 2 systems on board of this ship, so therefore there are also 2 vapor lines, 2 condensate lines, and 2 liquid lines. For each system, 1 line. Come back on that immediately. Let's first have a look to this rectangle here, which indicates our compressor room. The compressor room is here divided into three parts, three identical parts, namely installation 1, installation 2 is not completely drawn, but just indication of the elements in the installation, and then installation 3. So it is logic that for each system you have on board, that you have a separate and segregated installation, reliquefaction installation. So let's say that this port side 1 is for system 2, that the starboard 1 is for system 1, and the IMO requires that for each piece of the installation you have a spare part. So what is the logical solution? Instead of putting all these spare parts in, for example, the engine room or in a locker somewhere, what they do is they build with the spare parts, they build simply a third reliquefaction plant. Because in that way, the capacity, the cooling capacity has increased and the spares are used meaningfully. So we normally have system 2, system 1, and a spare unit. But a spare unit which you can connect to either system 1 or system 2, of course. There's a possibility to connect that, as we will see later on, to connect that to system 1 or to system 2. For the moment, you just keep in mind that we have for each system reliquefaction installation, and we have an additional spare one. The manifold configuration. So let's now have a look to here the manifold. You see here the manifold connections. These small lines, black lines here are the manifold connections. So in this case, you see 1, 2, 3, 4, 5, 6 manifold lines, 6 manifold flanges. All right, we start from aft to forward. Aft will have the booster line. The booster line is the line which is connected with the outlet of the heater. One of the videos we spoke between the connection of the booster pump, which is here, this deck-mounted pump. The pump that increases the pressure. It's in series with your cargo pump. It increases the pressure. Under pressure, it brings the liquid to the heater. And in the heater, this liquid is warmed up to warm liquid or warmer liquid. And then it is sent towards a special manifold, and that is the booster manifold. And in this case, on board of this vessel, is the most aft one. What is so special at this manifold? Well, the special thing at this manifold is that it can resist higher pressure up to 25 bars. It's not that you'll always discharge with 25 bar, but that is the maximum pressure it can resist to. So this is a DN300, while the others are only DN250. That means that the thickness, the wall thickness of the pipe has increased. It's really a thick pipe, and that the number of bolts at a manifold to connect this manifold has increased, has increased, and that the thickness of the flanges has increased. Altogether, solution or ID is that it can resist to up to 25 bars, while a normal manifold, the DN150, is something like 12 bars maximum, not more than that. Okay, that's our booster manifold. Then we'll have here the second most aft manifold is a liquid line. How do I see that it's a liquid line? Well, I see that because it's connected to a filter. This is the filter we always use when we are loading. So when we are loading, liquid is coming in from this manifold. We open this valve, it goes over the filter, and then it goes to the liquid header to distribute it between the different cargo tanks. If we discharge, we will not discharge over the filter, but we will use this bypass and send it to the manifold. This is liquid system 1, as mentioned here, system 1. We will go deeper into the system in the following slides, so don't bother too much about that. But this is system 1, since it's mentioned. But if you look to the drawing, you can deduct that is system 1. Okay, that was liquid. The next one, we got the vapor of system one. So liquid and vapor. Normally, liquid is indicated with on board of an LPG with a red line. On board of an LNG, it's more blue as used. But on boat for the vapor, we use yellow. So a yellow ring on that line that indicates this is a vapor line. The difference between both is that the vapor line has an insulation and that the diameter is a bit smaller than the liquid line. Normally, liquid line is something like 12 inches, while the vapor line is something like 10 inches. Okay, then we have an IG manifold. That's a small one here, which in reality is not small at all, but it's on the drawing, it's a small one. That is in the case you need, for example, nitrogen from shore. You can use that line. We don't have a nitrogen installation on board of this vessel. On board of an LPG, normally not. You don't need it very often neither, so it's not necessary to get that on board. Then we got the vapor of system 2, vapor manifold of system 2, and then we got the liquid manifold of system 2. The goal of these two systems is, of course, that you can take two different cargoes at the same time and that you can keep them fully segregated. That is the goal. Of course, these gases are also chemicals, so you should keep them fully segregated one from the other. Okay. Yeah, if meanwhile there are any questions on this, please don't hesitate to put it in the chat or to contact me. Stop me if you don't understand or if it's not clear what I'm telling you. If you don't interrupt me, then I presume that you understand, so I continue. Okay, that for the manifold. Here you see the manifold or one manifold. With the manifold connection, you see here a lot of bolts. This is quite some, but although this is only the N150, you see it to the thickness of this spool of this reduction piece. This is a reduction piece that goes from the size of our manifold or the ship's manifold towards the size of the terminal jigsaw. All right, the systems. The systems are mentioned here, but it's not so good readable, so I took it again here. What do we see? Well, we see that there are two systems on board of this vessel, system 1 and system 2. That's not so difficult. That means that this ship can take maximum 2 different cargoes at the same time. For example, 1 tank with propane and 2 tanks with ammonia. That is possible. Now, in these two systems, 1 and 2, you have 2 options, option A and option B. In option A, you got tank 1 and tank 3 connected to system 1, while on system 2, you have tank 2 connected. And option B, you have the option to connect tank 2 and 3 to system 1 and system 2 to tank 1. So there is no direct link between the systems and the tanks. The tanks are flexible. You can change them from system, except number 3, which is always on system 1. Tank number 3 is always on system 1. How do you do this connection? You make this connection with spool pieces. Spool pieces, that are these things. These are elbows, as we call it, and elbows, you can turn them, you can connect them either way. So if we go to this place here, for example, on our line plan, you see that this line ends here with a flange, and this line ends here with a flange, and there's a small trace, curved trace, which indicates an elbow. And so the option is you connect that elbow or you don't connect the elbow in this case. There is another place here where it's mentioned, I come here with a line and a flange, and then here is the 1 and there is a 2. This goes to system 1 and this goes to system 2. So this was the liquid to vaporizer. That means if I want to connect the vaporizer to system 1, well, I connect the elbow in a way that is connected upwards. If I connect the same elbow downwards, then the vaporizer is connected to system 2. So always where there is this small trace, bended trace, 90 degrees bend, that is where you, in real life, should place this elbow. A lot of connections to make, flanges to connect, joint to make it gas tight and watertight. A lot of work to do if you want a certain configuration. But okay, if it's simpler to say I want tank 1 and 3 to connect to system 1, but in real life it means a lot of bolts to tighten before you got this completed. Okay, good. Let's have a look now to the lines. The lines, I will use the red color for the liquid line, the yellow color for the vapor line, and this red for, blue for the condensate line. Just let me think one moment. How did I have that in mind? Okay, liquid line. The liquid line, the vapor line, condensate line. Okay, just a moment, because now I can give you a small task. Yes, that was why I was a bit doubting what I was thinking about. So liquid line, we go for option A. That means we want to connect tank 1 and 3, and we want to keep tank 2 segregated for another cargo. So let's say that 1 and 3 we take propane, and tank 2 we take for ammonia. So my question now to you is to connect or to prepare the connection that tank 1 and 3 is connected. So please draw or indicate with a red marker the liquid line for system 1. That means that somewhere you will be asked to make a connection between tank 1 and 3 to system 1. As you know, tank 3 is always on system 1, so that is for sure. So if you start on tank number 3, you're always right. So take a red marker and start drawing the liquid line for system 1 in the knowledge that tank 1 and 3 should be connected. And the liquid line of system 1, you can find also, of course, the manifold. Here, manifold. This is the liquid line number 1. Okay. I'll wait a few minutes so that you have the time to draw on your plan the liquid line of system 1. If in the meanwhile there are questions, please ask the questions. So make sure that you don't connect system 1 to system 2. Both systems must be physically segregated. Absolutely no connection in between both. And a valve is not a segregation, a valve is a separation. So that is insufficient as a segregation between system 1 and system 2. Okay, since it was the first one, maybe it's a difficult one. I have no idea if it's difficult for you or not. I cannot see it from here, but okay, the most logical thing is that you start at the manifold because that is the place uh, where your liquid will arrive when you start loading. So if you start at the manifold of the right system, system 1 in this case, then you are on this line. So this line is definitely part of system 1 and the liquid will enter by this connection. Okay, then as I mentioned, you go over the filter and then you go to the liquid header. When I say header, you have a liquid header, you have vapor header, IG header. Header always means that that is a line which is in the longitudinal direction, so going or running from forward to aft of the ship. Yes, that's the header. So I come here on this liquid line, liquid header. If I follow, I end here and they ask me to place a connection here. Well, I didn't ask you to connect the vaporizer because this line is mentioned liquid to vaporizer. So for the moment, I will not connect the vaporizer here because actually I don't need it. If I need it later on, I can still make that connection, of course. This line is always connected to tank number 3, as we've seen. System 1 is always connected to 3. So that means this most aft line is going to the pumps. Of course, it's the opposite way because the liquid will come from the pumps. This is a non-return valve here. This is the discharge valve. With this valve, we will regulate the flow coming out of our tanks. Since the RPM of the pumps is a fixed number, we cannot change it. It's an on-off button, and we will regulate the flow with this discharging valve. So the non-return valve will just make sure that during loading, there is no liquid passing over the pumps. We will not be loading over the pumps. That's different compared to chemical trade. So for the loading, this end here is blocked. I don't see my cursor here. Yeah, this end is blocked up. And this is then the loading line. So in fact, this is discharging line, this is loading line. The loading line goes up to the tank dome, and by this crossing here, we'll end up in what we call the tank filling valve. So the filling is the way how we load the tank. And here, just before that entrance into the tank, we have then the filling valve with which you can regulate the different flow between the tanks connected to the same system. If you say number one goes a bit too slow, or I'll close a little bit number three, sorry, then there's more liquid going to number one in case, for example, you have an excessive trim or something like that. So that's what we call the tank filling. Okay, that for number three, then we go forward and then we'll have this end. And here you clearly see that it's mentioned 1, 2, 3. So these are the numbers that indicate the connection to the tanks. We have here system 1 that we will connect now to tank 1. So when we go forward, we are on this line. Following the lines we have again on tank 1, the same thing as we have on tank 3, namely the discharge line connected to the pump dome and the loading line connected to the tank dome, with here the filling of tank number 1. That's exactly the same. That couldn't be a lot of a problem, I think. Okay, no questions about that? Well, let's have a look then to the vapor line. So take something like yellow marker or orange or something what you got in front of you, and try to find out for tank 1 and 3 the vapor line. Since you have already liquid line, it's a lot easier, of course. And start again at the vapor manifold of system 1. That's most logical place to start the line flow. Okay, vapor is not so difficult. Same thing, start at the manifold. System 1, you follow the line, and you got the gas header. We prefer to name it the vapor header, as they did here for system 2, but I don't know why. That's not really consequent, but for system 1 they use the name gas. I prefer vapor. Vapor header, I explained in the theoretical courses why I do so. So the vapor header here. And as you know, tank 3 is already connected, nothing to do here in real life, nothing to do. It makes it very easy to connect tank 3 to system 1. Okay, then we go forward, no connections here, so far so good. We go completely forward and we see that we have here another connection to make. So in real life, you need to go there, install the spool piece, the elbow, tighten the bolts, put the joints, and then so on and so on. Everything tightened. And then you made a connection between tank 3 and tank 1 on system 1. Then you can continue and you come here on the tank dome and the tank dome, and then it is here, as is stated here, the tank vapor valve. So the tank vapor valve, and then here just a hole in a tank at 100% connection with your vapor line. This is the vapor line of system 1. And then finally, the condensate line. There, of course, you have no manifold. There is no manifold of the condensate line. So we will start number 3. Number 3 with the sump heating and the top spray is mentioned here. That means that this valve you will use when you send your condensate to the top spray. So the students who have already seen my last video, they will know that in during the cool down, I will send top spray. That means I will send my cold liquid to the spray line and spray these small droplets inside the tank to cool it down. But there's another option. You can send it just to the top of the tank, but you can send it also to the bottom of the tank, to the sump. This is done when you don't need additional vapor at all, or when you don't want to cool down, or when you want to warm up your tank. Then you use the bottom end, and that is called sump heating. So you send your condensate either to the bottom, either to the top of your tank. Condensate of system 1 is going here and going here. I forgot to make the connection towards the plant. That is the line which is coming down here, and then I'm here, and then I'm going to this system here. This is the system 1. So I forgot to color the line which is coming down here. Okay. But here you can make whenever you need a connection to the deck tanks. So the deck tanks are always connected to the condensate line if you need them. But in this case, we'll connect 1 and 3. So we arrive here, and then with the condensate, we come again on the tank dome of tank number 1, where we have the option to put it at the bottom or at the top. And then we are looking at the whole system 1. These are the lines that we will use for the cargo management of system 1. So for one product. Then, of course, you can do exactly the same for system 2. Now, system 2 is a lot easier since you have only one tank. And tank 2 is quite close to the manifold, so it's quite easy job to add now the lines of tank 2. You might ask, why do we have these options? Why is it not 1 and 3 always together, and then tank 2 is a separate one? Well, this has to do with quantities, of course. Know that on most of the gas tankers, tank 1 is the smallest one. This has to do with the shape of the ship forward, of course. Tank 1 is really a small one. In most cases, tank 2 is the largest one, and tank 3 is a bit smaller than tank 2. So depending on the request of your owner or charterer, you can choose different options. Like, for example, if they ask you, well, you have to carry 2 cargoes, propane and ammonia, but from propane you should take as much as possible. Which option would you choose in that case, A or B? In that case, you should try to connect the 2 largest tanks. So in this case, tank 2 and 3 will be connected. That means that system 1 will be dedicated to the propane, while system 2 will be dedicated to the ammonia. That is the reason why you can manage, why you can change these connections of tanks to these 2 systems. In a case you have only one cargo, most of the time it's like that, to be honest. Let's assume that you have one cargo butane, ship full of butane, then you will make these connections. So at the manifold, you have two big elbow connections of the liquid lines and the vapor lines, which will connect system 1 with system 2. So from then on, when you insert these elbows here, you only have one system. And that helps because then you only have to connect one manifold. You can choose which one, the forward or the aft one, doesn't matter. But you have one system. You don't need to connect both manifolds. By connecting only one manifold, that's sufficient. You can reach your whole ship. So these elbows, these two here, are just to unify both systems to only one system. Okay, we're making progress. Good. This is something that might be interesting for next week. So I'll explain it now already, because that is something I will ask you to do for next week. People who have seen my last video, they know that we will always change the atmosphere in the tanks by the displacement method, by using the difference in density of the gases. So it can be that we'll have heavy gas inside the tank and we bring in a lighter one. Then we should bring our lighter ones top in and the heavier bottom out. So the connection, the practical connection, is done on the dome. And here you see 4 flanges, 1, 2, 3, 4 on the dome. The connections that you make here in real life, in practice, can be done all parallel. So that means that this flange will be connected, the left flange, upper left will be connected with the lower left, upper right will be connected with the lower right. Parallel connection. In that case, let's take IG from the engine room. I close this valve, then the IG is sent towards this connection, this first connection. Since are connected parallel, it goes here on this line, and this is the liquid line. So that means bottom in, and I come here top out, because this is the inert tank top. This is the top of the tank. An additional connection is connected again with the IG line, and then, as I mentioned, it goes into series to the next tank. So when I connect these 4 flanges in parallel, then I've chosen the option bottom in, top out. If this is Chinese for you, please look at my last video. The other possibility is that I cross the spool pieces, the connections. When I cross the connections, I come in with my IG, which is now crossed. That means that upper left is connected with lower right, and that I enter by the top. So top in, and I come bottom out. I go out to the next tank. So this is also a choice that you make, taking the density of the gases into account, whether you connect it in parallel or whether you connect it crossed. And of course, that you can do on the 3 tanks, on the 3 tank domes. So this is my last slide. I would like to ask you to prepare for next week. For this LPG, which is initially under air on this LinePlan, I would like you to make 3 different drawings. So you copy this plan 3 times, please. And you make, on the first one, an alignment. That means you indicate with a color. Since we are going to inert, you use a purple color. That will be very nice, even professional. So you draw You start in the engine room here where we have the IG generator. You start here in the engine room. You start with your IG coming from there. You see here there's also another non-return valve so that no gas can come into the engine room. You make a drawing for the inerting of all three tanks, as I explained in my last video, in series. We are on board of an LPG tanker, so that is in series. You do the same for the gassing up from the propane from the starboard deck tank. Gassing up from the starboard deck tank. I forgot to indicate that here on the slide. I will add it. Gassing up from the starboard deck tank. Starboard deck tank with propane. And then finally, on the third paper, you draw the lines, the lining up for the cooling down of all three tanks. Hope that is clear for you. And then I hope you can prepare that for next week, because I think that is an important task for you. That's one of the first things you should do whenever you go on board of a gas tanker. That is to study the line plan. If you do not understand the line plan, they will send you to a valve and you don't know where to go to. So it's very important that you know the line plan of your ship. Good. That's it for this week. Are there any questions about everything what I told you so far? Then I would like to hear that now. Okay. I hope you learned something from that, and then I would invite you to make this small task for next week. But of course, before you can do this, please look at my last video, and then you will understand how to do that. Without that video, that won't be clear. But I hope you all have the time to look at this last video for next week, where I will correct then this small task. Okay? Thank you very much, and see you next week then.